This is a deeper look at App Engine. If you were at my talk this morning, this will cover a lot of the same material. I'll try and move through that a little bit more quickly, and then we'll cover some more advanced topics. We'll get to the portion that I didn't get to this morning. And let me just do a few logistical things. I sometimes tend to talk a little quickly, and I also had a little caffeine, so I tend to talk even more quickly. So feel free to raise your hand and ask questions at any time, and it can be about anything you're interested in about App Engine. If you're sitting way off to the side, I might not see you as quickly, so you might want to move in more towards the center, but that's up to you. And I will try and repeat any questions that people ask. So I really encourage the questions because I care more about what you care about than what I care about. So that's my philosophy here. This is an overview of the talk. We're going to do a quick overview of Google App Engine. I'm going to talk to you a little bit more than Chris did this morning about why we're doing App Engine. I'll probably make one or two of the same jokes that he did because he stole those from me. And then I'm going to do a quick application walkthrough. I'm going to use some of the code that we talked about this morning in the code lab to show you a little bit how a App Engine application is structured. And then I'm going to talk about best practices. So there's a few best practices, things that I want to talk to you about, things to know about Google App Engine, particularly about about entities and keys, and also a best practice. I'm going to use counters as a example of how to go about doing some code. So that'll be a little bit deeper dive into some actual code itself. And along the way, we'll talk about GQL and memcache and all these sort of things. So before I go ahead and get started, I wanted to see if there were any questions. All right, excellent. Okay, so you saw this morning. I'm used to having screens nearby, so I can point to things, but I'll have to extrapolate. Okay, so this is our visualization of why we built the problems behind why we built App Engine. So you'll see on this side, which is your right side, my left, there's the LAMP stack. This is traditionally how people these days get started with application development. There are other stacks you can use, but this is one of the most common. So you have a Linux box with Apache on it, MySQL for your database, and then some P-named scripting language, PHP, Python, Perl, something like that. Well, as you get more popular, you have to add more machines. You have to start sharding your database. You have to do load balancing. And as you get more users, you have to keep doing that. You have to do that over and over again. And you'll see down in the center, we have some of the other kind of boxes of things you need to start adding. You have to do monitoring, add in more machines, go through your logs constantly, reconfigure your systems to handle this additional load. And you have to do all of this yourself, and all of this requires engineers and time and effort away from what you want to do for building your application. And then this center box here, this cache, this is the joke that Chris DeBono used too. This is a cache, it's C-A-S-H, it's money, it's not C-A-C-H-E, which is, memcache we will talk about a little bit later. So, all this stuff costs money, but it also costs time and effort away from what you are doing. So, what we thought is, we've solved all these problems for ourselves. Why can't we solve them for you as well? Why can't you run your web applications on our infrastructure? And that's what Google App Engine is. So here's some things we wanted to do. We wanted to make sure it was easy to start, and it was easy to scale, and it was always had a free component to it. So, all right, so I've given you the rationalization behind why we did it. Let me talk a little bit about what you get. You get 500 megabytes of storage, 2 gigabytes of bandwidth a day, and 5 million page views a month. This will always be free. We've made this commitment. And at some point, we'll actually start allowing you to give us money for it. At this point, we haven't done that because we haven't set up the mechanism for it, although we're in the process of doing that, and we've said that we're going to do this by the end of the year. And this is what our expected price is going to be. It's a pay-as-you-go model. You don't pay for what you don't use, so there's no monthly fee. CPU, storage, bandwidth outgoing, and bandwidth incoming. So these are things that you can expect to pay for. And one way to judge this is if you used essentially twice the free starting quota. If you used twice this amount, you would probably pay roughly $40 a month. Sorry, don't have a euro conversion right now. Okay, I want to come back to this slide for a second. I want to talk a little bit about some stuff that I don't actually have on the slides. I want to give a little bit of an overview of the services that we provide. So one of the key things that we provide in Google App Engine are we provide you with a distributed data store. We provide you with a platform where you don't have to worry about scaling. You don't have to worry about machines. You don't have to worry about configuring a web server. We've done all this stuff for you. We let you take HTTP requests and produce HTTP responses, all of that built on our infrastructure. You never have to worry about which machine your application is running on. You never have to worry about maintaining those machines or backing them up, because your applications are actually replicated across our data centers. So that's the core of what we provide. We provide a lot of services and APIs, which I can get into more later, and you'll see examples of. But that's the core basic essence of what we provide. So let's talk about things that you can't do on App Engine. App Engine is a pure Python runtime. That means that you can't run applications built in C or Java, or you can't refer to libraries that are built on that. An App Engine application cannot write to the file system, cannot open a socket or access another host directly. It has to communicate via HTTP requests and responses. You can't spawn a subprocess or a thread. And you can't make other types of system calls, such as signals. So that's pretty much it, though. Anything else that you want to write in pure Python, or if you want to bring in Python libraries that other people have written, open source applications, or code that other people have constructed that don't do these things, then you are free to do that. Okay, so what's next? The first thing that everybody asks about is more languages, and we have committed to allowing more languages and creating new runtimes for different languages. We have not announced what those are going to be, and I can't answer you when you ask me what those languages are. We've also, as I outlined, we're going to allow you to purchase additional capacity. So that we've committed to doing by the end of this year. We want to do a large upload and download support. Currently, you can bulk upload CSV files, but you cannot bulk download them. You can set up your own process for creating a download, but we'd like to, for data portability reasons, we'd like to give you the ability to do that. Can't do offline processing, so you can't run long-running processes that, for instance, take a image and tile it up and reproject it and all that sort of thing. At this point, you can't do that, but everything has to go through an HTTP request and response, and the response has to respond within 10 seconds. But we are going to add that. We also want to add support for large files, particularly aimed at media files. So giving you the ability to upload, a video or images. And the reason right now that this is an issue is that at the moment, your entities are all limited to 1 megabyte in size, as is all your response. So those are some limitations we're hoping to get around. And the final thing is cron jobs. So, the ability to run the same job over and over again at a specified time or a specified interval. Okay, so our FAQs. So what about a service level agreement? So currently we haven't provided a service level agreement, but we are working on figuring out what's the best way to provide you with the information you need about our uptime. And what is that what particulars of information that you would need. We have worked with Cloud Status, who provides a dashboard, and for us, telling what our uptime has been. You can look at that historically as well as the current status. And we've also added some to the dashboard online. We've added some more to that dashboard, so you can look at that for status as well. But we haven't provided an SLA because we are trying to figure out what's the best information that you need in that SLA and what's the things that we can guarantee the most. Another question we often get is on lock-in. So I already talked about data lock-in. At this point, we're committed to data portability. We would like you to be able to get your data out of us easily. However, we are also committed to code portability. So at the moment, if you write your code for App Engine, it runs on App Engine. And that means because it's pure Python, it gives you the opportunity to run it on other servers, but no other servers run App Engine. Except we do provide you with our development server, which is an open source project, so you can run those in your own systems. Also, there are open source projects for a number of the APIs that we have, or most of the APIs that we have, including our data store, Bigtable. So there are other people, and you could adapt your code to those servers, to those projects. Another thing people ask me a lot of is, can I get more quota? And yes, at this point, we do have a process for you to bump up more quota. There's a form you can fill out online. Generally, your project has to already be nearing or threatening to near getting near your maximum quota. And then the other question I get is, what's the next language? And I sort of have to say this at least 3 times before people really believe me, but I cannot announce what the next language is. I will tell you, just for you, I will tell you it won't be COBOL. And it won't be Fortran, and it won't be QBasic. I can't tell you otherwise, though. Okay, so any questions on anything I've gone over so far? Yes? You have no write access to the file system. You have read access. 500 megabytes. That's right. You have 500 megabytes. That's for your space in the data store. That's the 500 megabyte. So the 500 megabyte limit is the limit of amount of data you can store in the data store. You have no access to the file system to write files. You can upload up to 1,000 static files, including your code, to App Engine. But the 500 megabyte limit is for the amount of data that you can store in Bigtable. Any other questions? Yes. Is there any plans to reduce the time allowance? You mean the amount of time to reduce the limit on the amount of time? To increase it. Okay, so you're wondering if there's any plans to increase the amount of time that we allow. So currently, HTTP requests have to be responded to within 10 seconds, or the request just fails. We have not announced any plans along those lines. So one thing you may notice is that Googlers tend to be a little secretive. App Engine is actually pretty open about what our plans are, what our roadmap is, but a lot of times we can't actually discuss anything. We can't discuss our plans, and that's a Google thing. We don't want to sort of announce something, very far in advance, and then have you build towards expectations of it, and then it not happen, or it not happen the way that we said it would. That's one of the reasons, and there's a variety of other things. So basically, Googlers are often in the position of saying, we haven't announced anything, which means we can't say one way or the other. So, any other questions? Yes? We support Django templating, Django 0.96. Also, there are a number of people who have ported, because Django is almost entirely, Django 1.0 is almost entirely in pure Python, then they've ported those portions, there's a few things in there like GeoDjango, which require some C libraries, which are not supported. So I think I said this earlier, it's pure Python, which means you can't use anything that relies on a C library or Java library or anything that's not Python itself. But so there are people that ported Django 1.0 to App Engine, and if you do a search on it, you'll see there's somebody who's done actually a walkthrough on how to do it. Well, yeah, we have, as I said, we have Django 0.96 templating, but not the rest of Django. App Engine itself is very much like, draws a lot of inspiration from Django in terms of how the models and entities work, et cetera. Yeah. Well, so the question is on how do you do testing on App Engine, functional tests, unit tests. Because you can't run ongoing processes on App Engine, you have to initiate the test from outside. There's a couple of articles on doing unit tests on Google App Engine, I think written by people who are not at Google, but they're good articles. So there are people who do that. We don't provide a testing framework. We do provide a development server, which you can certainly use as used for testing, but it doesn't use the unit testing part of it. Yes. Subdomains. So you can handle subdomains with the request handlers. Basically, you can set regular expressions in your app.yaml file for things that come in, and you can do it that way. We don't, I think, provide support for naked domains at this point, which is instead of www dot, it just, dot, or not dot, but, what am I trying to say? So instead of www.foo.com, it would just be foo.com. Yeah, so we don't, I think we don't provide support for that. We do, I think I didn't mention this in my slides, but if you want to run the application on appspot.com and have that be your domain, we're happy to have you do that, or you can run it on your own domain. It still runs on our servers, but you just, we have a setup process for doing that. Other questions? Yes? So the question is on indexes and whether or not we allow indexes on all our properties, particularly around full text, for doing full text search. Full text search is not supported at this point. We do allow indexes on all our properties and including multiple properties per entity, but we don't, the two properties we don't allow indexes on are the text property and the blob property. So basically the big, large properties. You can do it on strings, and you could do a search on string, but as far as full text search, it doesn't. We don't have that capacity at this point. It's one of our more frequently requested features, though, and if you go to our issue tracker and add your star to the request for full text search, then we certainly look at that and in determining what features we're going to add. I'm sorry, it means that you're limited to tree-like data structures? Is that what you said? Okay, so I mean, you can do things like you could add a list of tags if you wanted to do search on specific keyword search. You could add a list of those tags to as a list property on your entity. Any other questions? Great. Okay, so I am going to bet that doesn't show up very well. But if you do a search on Google App Engine Code Lab, this is the code that I'm going to be drawing on. This is the same, as I said earlier, it's the same code from the Code Lab that we did this morning, and it's just the basic code from step one. And so what I wanted to show you was the basics of what you need in an App Engine application. So you'll see here we have an app.yaml file. An app.yaml file is a configuration file, essentially. It tells the application, it tells App Engine what the application name is. As you see here, it says application, what version it is. That's under your control, the major version number. The minor version numbers are controlled by appengine.com. Google.com, sorry. Tells it what the runtime is, which is Python. Don't bother trying to put in C# or some other programming language. It won't work. And the API version, which is just one. It's our API version number. And then a list of handlers that you can use to direct HTTP requests to individual scripts. You can also use this for requiring logon to access particular URLs. Okay, so the next thing I want to show you is the model. So models are classes essentially that define the kind of data that you're going to store, and then you instantiate the class as an object before you put it into the data store. So you'll see here that it's a class and uses the DB model class. It's got three properties: title, body, and author. This is from a wiki application. So assume a very simple wiki page will have just a title, which in this case is a string property, a body, which is a text property, which, as we mentioned before, is not indexed, and an author. And the author is a user property, and that basically takes a user object from our user API. we provide an API for you to use for authentication, which is using Google accounts. So you can either use a Gmail or a Google Apps for your domain account there. Okay, and then I wanted to go over fairly briefly the main.py file. So you see, we saw in the app.yaml file that every request in this application is sent to main.py. And then at the bottom here, you see this code, which I'm sorry still goes off goes off to the right here, but this is the main meat of it. So every request comes into here, and then this defines which handlers, and I'll show you a handler in a minute, handle which types of requests. So basically, anything that goes to slash goes to the main handler. Anything that goes to view slash something goes to the view handler. Anything that goes to edit goes to the edit handler, and anything that goes to save goes to the save handler. And then the handlers determine how these, they then process the requests. So I'm going to show you the edit handler just briefly. So you'll see it extends a base request handler. The base request handler basically defines how to generate a template for the application. It's not, it has one generate function in it. You can look over that more closely if you want. And I lost my place. Okay, here we go. So you'll see that in a, there's a few, each request handler takes has a few different functions in it to handle the different types of HTTP requests, as well as you can have any other types of functions in there that you define. But if you use, for instance, the GET function, any HTTP GET request that is handled by that request handler will then be handled by the GET function. So the GET function takes the page title and the current user, and I'm sorry, it takes the page title. It looks and sees if there's a current user, and if there isn't, then it'll direct somebody to actually log in. And then it creates an entry. First, it actually looks to see if an entry exists. I guess in an edit one, it's already decided that it exists. But you see, it creates an entry object by looking at this wiki page. So it says wikipage.gql. So it looks in the wiki page entities, and it searches for the particular title, and then it gets the first one that comes up. And there should only be one. And then it just sends it uses generate, which is that function that comes from the base request handler, to generate use the template to generate a response. So it basically takes the edit HTML, passes it these values, which is the page title and the entry object, the entry entity, and then the template then knows what to do with how to process them. And then I happen to know that the edit HTML page has a save button on it, and you click the save, and it posts the response. So you'll see here in the save handler, it defines a post function. So any posts that come to it, it then handles those. It handles that request, and basically it goes through. It creates it takes the entity. If the entity exists, it edits the entity, changes the body and author, and then puts it into the data store. And if it doesn't exist, it creates one with those values. And then you see here, entry.put. That's all that's required to add an entity to the data store. And then it does a redirect to view the page that's been created. Okay, so that's a basic walkthrough of the code. Shows you some of the really basic functions of Google App Engine. I didn't want to spend too much time on this code walkthrough, but I wanted to see if there's any questions on anything I've talked about so far. Any questions? No? Okay, great. Yes? Uh-huh. Mm-hmm. And it failed on you? You did you tried to query for it's mostly a Python thing, so you have to look at Python date times and how they interact. They're actually kind of complicated, but I'm sorry? Oh, in GQuo. So you tried to query on the year for later if you want. I'll take a look at your code and we can see if we can figure out what was going on there. Any other questions? Did you have another one? Oh, okay. All right, great. Okay, so I did the basic walkthrough. Now I want to talk to you about some things that you should know, essentially, about your tools for storing data. So basically, I want to talk to you about a little bit more about entities. Then I want to talk to you about keys, and then transactions. And then I'm going to talk to you about counters, which are a really interesting example of how the data store is different from a traditional relational database. Okay, so these are important things to know about entities. They're the fundamental storage type in App Engine. They're essentially a bag of property name value pairs. It would be a mistake to think of them exactly as rows because they're really not. They're just a set of name value pairs. Most properties are indexed and therefore efficient to query, but as we mentioned before, blobs and texts are not. Think of it as an object store, not a relational database. This is a key point. I think I've mentioned it before, but I think it bears repeating. The kinds are your models or your classes, and the entities are like object instances. You can create relationships between entities, but you cannot create relationships between tables because essentially you don't have tables. You have a big table. That's our data store name. But that table is like a hash table, not like a database table. So that's an important thing to think about. The big table itself is basically a giant hash table distributed over multiple systems, where it is not a database table. So you can create relationships between individual entities, but not between tables in the database sense. And the relationship is created using keys, which I'll talk about a little bit more, but it's using the reference property, which allows you to do one-to-one and one-to-many relationships. Okay, so keys. Every entity in Bigtable has a key. So whether or not you define it using a key name, or you allow App Engine to define it. Once you put an entity into the data store, it has a key. That key uniquely identifies it in the data store, and you can use it for very effective querying. If you know that key, you can just do a model.get. So in the case of the wiki application, if you did a wiki page.get on the key, it would very quickly pull that out, much more quickly than using GQL, which requires running a query on all the entities and figuring out which one is the right one. So some of the limitations are you can only have one key or key name per entity, and once it is set, once you have put the entity into the database for the first time, that key is set, or that key name that you've defined as you're creating the entity. Those are set in the data store, and they cannot be changed. They're also limited to 500 bytes. It's actually a fairly big size, but some people do run up against that, that limitation. So we always mention it. Yes? You'll get an error when you try and put it in. Okay. Another thing you should think about is using transactions. Transactions allow you to do traditional ACID transactions. Atomicity, consistency, isolation, and durability. This is a standard database concept. One thing to think about is you can't do a transaction in a query. So GQL doesn't have all this stuff that SQL has, where you can update or insert or create a table or create a database all within a SQL query. Instead, you have to do the query and then run your transactions on that on your particular entity. And for instance, what you would do is you would do a get to get the entity out of the query, and then you would make your updates, and then you would put it back into the data store. Okay. So I'm going to, in a minute, I'm going to push into counters. But that'll be involve getting more into the code and doing a little bit more deeper dive into some code. I wanted to see if there's any questions on anything we talked about so far. No? Okay. Yes. Sure. Ask me about it afterwards then. Let me go through the counters first. Any other questions? Yes. Yes. So your question is there, like other distributed hash tables, is there essentially, are you looking at race conditions on a particular? Oh, if you're asking if two things are trying to write and then read at the same time, are you going to get some lag between when the data actually shows up in? That's possible. It would be a very, very short period of time, and it'd have to happen very quickly. I'm going to talk in a minute about how to avoid that using counters. But yeah, I mean, there's some potential for that in any distributed system. Yes. What part of an entity are taken into account when calculating a session? I'm not sure I follow the question. Yes. The hash is the key. On which, if you use a known key, do you have an influence on which packet? So you're concerned what would happen if two entities had the same hash? So App Engine will take care of that if you're just allowing the key construction. If you attempt to put in an entity that has the same key name as another that where you're defining your own key, it will detect whether or not one already exists. Yeah, we obscure a lot of that from you. Basically, if you're working with App Engine, you're sort of choosing to not handle those kind of things on your own and just trust us that it works. And I know that for a lot of developers, just trusting us is kind of a little bit hard, but we've been doing this for a while, and I think we've gotten pretty good at it. So I see a few of you laughing at the just trust us. Yeah, I mean, it's a good question, and if you want to know more about how it works, come over to work at Google. So, okay. So counters. Knowing how many entities of a particular type are in your data store is one of those challenges of distributed systems. So in any distributed system, but particularly in Bigtable, we don't keep track of how many entities there are of a particular type. It's one of these performance issues that we just feel like if we had to keep track of it, like in a relational database, the database always knows how many rows are in a particular table. But because it's distributed over all these different systems, it's not efficient for us to keep calculating this. So you have to essentially you have to construct your own. So model gives a feature, a function, count. So you can call model.count. So for instance, you could go to, in the wiki example, say wikipage.count and get a count of all the wiki pages, except there's two issues with that. One is no query, which essentially you would be doing, returns more than 1,000 results in App Engine. So you would have to actually construct a number of GQL queries to get numbers over 1,000. The other is that it's very expensive in terms of CPU usage. And one of the big things that you'll want to do is avoid doing using the CPU a lot, because that's what you'll end up paying for. So the solution that a lot of people come up with is to create a counter entity. So an entity that counts the number of entities of a particular type, and you just increment it whenever something is added and decrement it when it's deleted. So there's a problem with having a single entity do this. Frequent updates equals a high contention. So there's a lot of, you can slow down because a number of different things are trying to write to the same entity. You might also, if you're doing transactional writes, they're serialized, and therefore it's slow. You get a lot of things just sort of stacking up, waiting for the write. And that could actually impinge on your 10-second response time. And basically, this is a fundamental limitation of distributed systems. So this is a best practice. Use a sharded counter. So basically what you do is you shard your counters into multiple entity groups. If you want to learn more about entity groups, there are ways to associate entities with each other, and you can provide ancestors for particular entities. And that allows for more efficient querying. So if you want to learn more about those, there's more in the documentation on that. So then once you've created a counter and you created multiple shards, you pick an entity at random and update that counter transactionally. You can then, when you want to figure out how many entities there are of a particular type at a particular moment, you combine your sharded entities together on reads. So this reduces the contention by a fairly significant amount. And your sharding factor can be changed with very little difficulty. So if you need to, if you're still getting some contention, it's still slowing down, you can increase that count fairly dramatically, very easily. Okay. So what does this look like in terms of actual code? By the way, does anybody have any questions on why we're doing this and what's, anything actually on anything at this point? Okay, great. So the code for this is fairly simple. You create a counter configuration model for your counter configuration entities. You give it a name and a number of shards. Then you create a counter model for each of the shards. And that gives a name as well as an integer count property. Okay, so to get the count, you pass a function, a get count function, the name. You set the total equals 0, and then you iterate through the counters that match that name, and add to the total number of counts. Okay, so to increment the count, which you'd want to do every time an entity was added, you would do this. You would create an increment function which looks at config. Basically, it detects whether or not there is already a counter configuration, and if there is, it uses that. If there's not, it creates it. So this is one of those lesser used functions on model that I want to highlight, the get or insert. This is a function available to you. It basically says if an entity exists, get it. If it doesn't, create it. I think that's, just wanted to call that one out. Then you define a transaction which assigns a random number between the shard, between 0 and the number of shards minus 1. And it creates a name for a shard based on the name of the type of thing that you're querying on, and adding in this random number. And then it gets by key name that particular counter. And if that counter doesn't exist, it creates it. And then it iterates the counter by 1 and puts the counter back into the data store. Okay, so that's a fairly simple example of doing that. But we want to figure out a way to, oh, yes. It's right there. Key name equals this, the shard name that you just defined. Sure. Okay, so we want to reduce even further the amount of CPU usage that you use, because there's two objectives here. We want you to build applications that are as cheap as possible for you to run. You're paying us as little as possible, and I know that sounds weird, but we benefit mostly from both from your usage of our service, but also from the searches that we get that lead to your service. But it also helps our servers run more efficiently if you're storing some of this information in memory instead of writing it to the data store every time. So we're going to use memcache. And memcache is something we introduced back in May. It was an addition, late May. It was an addition to additional API. And it's the same as memcached that a lot of you might be familiar with from running your own systems. It's exactly the same. It's a way for you to store in memory key value pairs, which you can then access that. You can access those numbers, those key value pairs, without having to query the data store. And that's essentially, to you, it's free, right? You store that in memory, and it's free. Now, memcache will store it as long as you tell it to store it, or if it needs the memory. So you do risk that anything you store that's not written to data store, anything that's there, then you might lose it. So that's why you write anything that you're storing in memcache into your data store, and then you just put it into memcache, and it sits around until either we need the memory or you or you decide you gave it a length of time. So this is a way to get the count that you might have that you would have created. Total equals memcache.get the name. It's very simple. You basically look and see, have I gotten this number before? If I've gotten it recently, give me that number back. And then if the and I think I apologize. The indentation on this is not correct. You'll see where the for counter should be shifted over. So basically, what this says is, if you don't have the total in memory, then pull it out of the data store and then return it. Otherwise, get it directly out of memory. Okay, so this is how it actually gets into memory. It's very similar to the process that we used for storing it into the count in the data store. You do the same counter configuration, the same creation of the counter, and and then you basically store it into you store it in memcache at the same time. So basically here you see this is all the same. You're creating the counter, you're storing it, you're iterating the count, you're putting the count into the data store. And then here you just use memcache increment, which allows you to create a value if it doesn't exist, or just increment it if it already does. It's a very simple piece of the API, INCR. And then it adds that to the cache, and then you can read it back out here. So one thing I didn't note in here is when you're adding something to memcache, it sits there for a certain number of seconds. And in this one particularly, we called out that it sits there for 60 seconds. So there's one thing that you might have noticed here is there's a possibility that your count is 60 seconds out of date. And that's a possibility we allowed for in this, that you may decide, and you probably will decide, that it's perfectly fine to have your count be not the exact count that of everything there is at this exact moment, but that you allow for a certain amount of time, a certain amount of flexibility in that number, and that you'll check again in 60 seconds to see if there's if there's a newer number. Okay, so any questions on what we went over there? Yes. I'm sorry, I didn't understand the question. How do you know? You have long run. You ask if you have long running functions in your code. How do you get any notice of? Mm-hmm. Right. So, how do you know if it's expensive to right? So, well, first of all, you can't run. Just to be clear, you can't run long-running processes in App Engine at this point. You have a 10-second limit. Everything happens between the HTTP request and response. So there's not really long running. So what we're wondering about more is you build an application, and how do you know how frequently you're doing the querying, and how do you know how frequently the and how expensive that is? And basic answer is for counters, you set the number of shards at like 100 or 150. It's not going to be extremely expensive. If you're running that, if you're getting that count very frequently, it's going to be more expensive. So, I mean, I think one of the things you're asking is how do you do profiling in App Engine? And that's a really good question. I haven't actually run into somebody who's doing profiling in App Engine. You can do a certain amount with writing things to your logs if you if you want to, and our logs are available online, and they're not, and you can download those and do some processing there, which would then tell you how frequently you're running things. Also, the dashboard will give you historical data on how much CPU usage you are using. It won't identify particular queries that you're using, but you could compare it to the logs and see time-wise, which queries are running when and what, whether or not your CPU's usage is jumping. So if you log into your account at appengine.google.com, you can view your logs there and download them as well. I'm sorry, what? Yes, it requires that your application be running on our servers. That's right. I don't believe that the development server administration console has logs, but it might. The problem is you can't really make a good comparison between them because the version of Bigtable in the development server is running on a single machine and not multiple machines. One thing you could do if you were curious and interested and you had only you only had a few applications already, is you could run a separate application on App Engine that's it's not your production server, but it's sort of a development server there that you use as well. You run the risk of that being discovered by somebody else, but you could set logins and that sort of thing to prevent that. Any other questions on? I only have one more slide, so I just wanted to call out a few more features of Memcache. These are all the functions that you have access to. You can add and set values. You can get values. You can delete them. You can increment them and decrement them, replace them. You can flush your memory cache, and you can get stats. So on what's in Memcache at the moment. So those are just wanted to call those particular things out. And if you want to learn more about App Engine, this is the URL. At this point, we have probably about 15 minutes for questions. And if I don't have questions from you, I'll just wander around and show code. I'll go through code that I have on other things. But I'd much rather answer your questions and get as much information from you as I can. Yes? So you're concerned about the data that is stored. There's a few different aspects of privacy. So if you're concerned that whether or not Google looks at any of that data, we don't. We don't examine your data. It's also not accessible from another application. There's no way for you to write an application that accesses somebody else's data unless they set up a specific HTTP response for you to get that. So those are the main, what we think of as the main concerns. Having been in Europe, there's some other concerns around privacy in terms of having applications running on servers in the United States and concerns about the U.S. Patriot Act and that sort of thing. We are an American company, so we are subject to American laws, and we also have no way in App Engine for you to designate, only run them in servers that run in Europe or something like that. So we can't. That's one of the things I've been asked a lot in Europe, and there's not a really great answer for that at this point beyond what I just said. So just have to sort of hope you don't get subpoenaed by the U.S. government. Were there any other privacy concerns you had? Okay. Other questions? Yes. Is Unicode supported? Yes. Yeah, it's just Python. You designate the encoding, the Unicode encoding. So usually UTF-8. Yeah, absolutely. Strings can be of any Unicode type. It's one of the things you have to do, though. Like if you designate the strings by default, it'll end up being, whatever the US standard US encoding is, so, or English encodings. Yeah. You had another question? Mm-hmm. So I missed the last bit. It sounded like you were asking you want to store text files in App Engine and load them onto the development server, and then eventually load that into onto the online App Engine. What you want to know is about encoding for it in terms of Unicode or. So there's two ways you could do that. One is you can store the text files as blobs in the blob property, in which case it's just a binary blob, and then it's whatever is in that, whatever the encoding is there. Yes. Right. Okay. Yes. So you're taking, your question is if you have an HTML file that you're using as a static file or as a template? As a static file. And you upload that to App Engine, it will preserve whatever encoding. It'll preserve the file however you created it. So whatever the encoding is there, it will upload that to App Engine. Yes. Yes. So the question is whether or not we're going to be supporting HTTPS. Yeah, currently we don't, but it's one of the things that we should be releasing within the short term. Yeah. So yeah, we will support that. I can't give you a specific date on when that's going to happen. Okay. Other questions? Yes. Well, so that's a complex question. The shorter answer is no, but the bigger answer is essentially everything is running on, on top of, or not everything, but almost everything is running on top of Bigtable and the APIs that we provide. Are there applications that were developed directly in Google App Engine? Not at this point, but it's not something we rule out for the future. I think it's I know a lot of people internally are looking at that and saying, wow, that's actually a lot easier to code in than our own infrastructure, creating our own infrastructure around it. So there's a lot of interest in doing that. And I wouldn't be surprised if in the future some Google applications are running on top of that. Yes? Interfaces to other applications hosted on a different domain. You would have to be through an HTTP interface. So you can do, say, a RESTful call to another application using a URL fetch, for instance. Has to complete within 4 seconds. You can also do a post to another domain as well. You cannot create a direct socket connection to Google to another application, or accept any, of course, as well. Other questions? Yes. Yes. 10 seconds is. So the question is whether or not we would support longer running requests. Mm-hmm. Yeah. Okay. So you're asking if you can do sort of MapReduce kind of jobs. That's one of our more frequently requested features. In the future, when we support more long-running processes, it's possible that we'll support MapReduce. We haven't announced anything around that. One thing that's interesting, actually, is that a Googler was sort of frustrated by this, and he went and released an open source library that runs MapReduce on top of App Engine. Now, I don't know. I haven't actually tried it myself, so I'm not sure how well it works. But it basically stores the processes in entities and then uses maps them that way, and calls when it does a call, it does a bunch of requests to these different entities that then launch more processes. That's obviously not very effective when you have this fairly low quota comparatively, but it might be something that when you're able to purchase more quota would be an interesting start point for that. I think that we don't rule out using MapReduce. Obviously, we actually created MapReduce and released it to the world, and I think it's a really great function of really great use for something like EC2. And in fact, we've seen a few applications where they use Google App Engine as a front end for doing serving data that's coming in more dynamically, and then they use EC2 for generating long-running processes of that nature. So, yeah, there's a lot of potential in there, and I can't really say more than that. Any other questions? Yes. That's a really good question. I don't know if there's any specific limitation. I admit it to not being a lawyer. I don't know if there's any limitations on specific type of applications, but there's no limitation against commercial usage. So it's possible that we make some limitations about the type of content, say content that's illegal or or is pornographic or something of that nature. You'd have to look specifically in the terms of use, but we explicitly want people to build commercial applications on top of this. We do not want you to feel like we're doing some sort of limit on those commercial applications. There's a couple other things that I should mention that have come up as questions since I've made these slides. One, people have asked, are we going to run advertisements on your applications? We will not run advertisements on your applications unless you sign up for AdSense and put them on there. it's not like some of our other free services that are ads driven. We, if you choose to run it on your domain rather than appspot.com, there is nothing that will indicate to anybody what the application is when they're viewing a web application. I'm sorry, was there another question? No. So there was that, and then the other question is, do we look through your data to search it, add it to indexing? We don't do that. I mean, if you create a website and put in a sitemap and all that sort of thing, then we're happy to index it in the usual way a web application is indexed, but we will not go through your data store and index that for web search. And did you have a question? It's distributed and replicated around your applications are distributed and replicated around the world. So if somebody's querying from Europe, depending on the network routing, it's most likely going to hit a European data center. But that being said, somebody in the United States will hit the same application, and it's most likely hit a U.S. data center. So it's, your applications are replicated into different points in the world. What does that mean for the lag in replication? By milliseconds. Yeah. By milliseconds. Yes. Mm-hmm.
Does it make sense to store the pictures in the big table? Because if
Sure.
users have pictures maybe about 100 kilobytes and you have 500 megabytes of limit, you can calculate that you have in your community maximum of 5,000 users.
Right. So you can apply for more quota, which we've given routinely for people who do that. 100 megabytes is a large is a large image. Well, it's not a super large image file, but it's if you're talking about user profiles. Whoops. Sorry about that. If you're talking about user profiles, generally you're talking about much smaller images, and those generally people will store in the blob properties. Yeah. Oh, I see. Mm-hmm. Right. So this is one of the reasons that we want to introduce support for larger files. So that's one of the things that's on our roadmap. What some people are doing at this point is storing the data in, say, Amazon's S3, which allows you to do to store larger files.
Because in the normal data query, you do not store pictures as blocks in the database itself.
Right.
You have to link the URL or something in the
Right.
store. So,
Yes.
I asked me how or where should I store the pictures on an external server or something.
If you're at this point, if you are building up large collections of larger images, then it would make sense to do something else like Amazon's S3 or your own server somewhere else. That would be my recommendation if you're concerned about running up against your storage limits. Absolutely. And that's one of the things that we mean by the cloud, right? Is you can get services from us and you can get services from somewhere else and you can run things on your own servers. So that's how we think about the cloud computing. Other questions? Cool. I think we're actually out of time. So thank you all for coming. We're going to be doing a wrap-up a little bit later. But thanks all for coming, and enjoy the wrap-up and the party.